Hey everyone, let's tackle this Leetcode problem, finding 3-digit even numbers. It sounds specific, but don't worry, we'll break it down step by step. The goal is to understand the rules and figure out a smart way to find the answers. Ready? Let's go. Okay, so here's the deal. We're given a list of single digits. This list might have duplicates, like multiple 2s or 0s. Our job is to see if we can pick any 3 digits from this list and arrange them to form a 3-digit even number. There are a couple of important rules. The number can't start with a 0, so no numbers like 0, 1, 2, and it must be even. We need to find all the unique 3-digit even numbers we can possibly make, and then return them in a sorted list. Simple enough. We get a list of digits, we make numbers, check the rules, collect the unique ones, and sort them. Let's walk through an example. Suppose our input list, called, has the numbers 2, 1, 3, and 0. We need to find 3-digit even numbers. Can we make 102? Yes, because we have a and a available in our list, and 102 is even. How about 120? Yep, we have a and a, and it's even. 130? We have, yes, it's even. 132? Got, yes, even. We keep doing this. 210? Yes. 302? Yes. We find all possibilities like 312 and 320. Notice 012 isn't allowed because it starts with 0, and 213 isn't allowed because it's odd. Finally, we collect all the valid ones we found and sort them to get the output list. So the first idea might be, well, let's just try grabbing any 3 digits from the input list and see if they make a valid number. But wait, the input list can have duplicates. Like, if we have 2, 2, 8, 8, 2, we can use the digit multiple times, right? We need a way to make sure that when we try to form a number, say, 288, we actually have 1 and 2 available in our original list. Just picking 3 positions from the list might get complicated with duplicates. How can we efficiently keep track of what digits we have and how many of each? Okay, here's a cleaner idea. Instead of picking digits from the list one by one and getting tangled up, what if we first just count how many of each digit we have? Like, for the input 2130 we have 1, 1, 1, and 1. For 22882 we have 3 and 2. Let's store these counts. Think of it like having a little inventory of our available digits. Now that we have our digit inventory, we can flip the problem around. Instead of building numbers from digits, let's test potential numbers. What are the possible numbers we could form? They have to be 3 digits, even, and not start with 0. So the smallest is 100. The next even one is 102, all the way up to 998. We can just loop through all these potential candidates. For each candidate number, like say 320, we break it down into its digits. Then we check our inventory. Do we have at least 1? Yes. At least 1? Yes. At least 1? Yes. Great. So 320 is a valid number we can make. Let's try checking another candidate. Say we're testing the number 322. It needs 1 and 2. Let's look at our inventory from the input. 2, 1, 3, 0. We have 1, 1, 1, and 1. Do we have the required digits for 322? We need 1. Yes, we have 1. We need 2. We only have 1 in our inventory. So we cannot form 322 from the digits 2, 1, 3, 0. This checking process becomes really straightforward with the counts. Okay, here's the Python code using that frequency count idea. Don't worry if it looks like a lot at first glance, we'll go through the main parts nice and slow. It follows the logic we just discussed. Count first, then check candidates. First up, this line is where we create our inventory. We use something called a query create, which is super handy in Python. We give it our input list, the one named, and it automatically counts how many times each digit appears. So if was 2, 1, 3, 0, digit counts would know 1, 0, 1, 1, 1, 2, 1, 3. Easy peasy. Next we start a loop. This loop goes through potential numbers, which we call it starts at 100, goes up to, but doesn't include, 999, and importantly, it steps by 2 each time. This automatically makes sure we only consider even numbers. Inside the loop, for each we figure out its hundreds digit, Let's call it its tens digit and its units digit. These calculations just use simple division and the remainder operation, often called to pick the number apart. Now for the number we're currently looking at, like 320, we figure out what digits it needs. We use the again on its digits and to get the required counts. Then, we assume it's possible to make this number, setting to true. We loop through each digit required by, like, and its required count. We compare this required count to the count we have available in our original inventory, the digit counts we made at the start. If, for any digit, our available count is less than the required count, then it's impossible. We set to false, and we can stop checking for this. Finally, after checking all the required digits for the current number, if our flag is still true, it means we can make this number. So, we add it to our list. Since we check the numbers in increasing order, from 100 up to 998, our list will automatically be sorted. So, we just return this list at the end. If we had used a data structure earlier to automatically handle uniqueness, we would need to convert it to a list and sort it here. But building the list directly works perfectly because our loop is ordered. So how efficient is this approach? Let's think about time. First, we count the digits in the input list. If the input list has digits, this takes about steps, which we call order n, or big O of n. Then, we loop through potential numbers from 100 to 998. That's a fixed number of checks, about 450, which is constant time. It doesn't depend on how big the input list is. Inside the loop, checking counts is also very fast, basically constant. Adding to the result list is fast too. So the main time cost is that initial counting, order n. Pretty good. How about memory space? We store the counts of digits 0 through 9, that's constant space, order 1. We also store the results. If there are valid numbers, we need space for them. So, order k space. Overall, it's quite efficient. Alright, let's quickly recap. The problem asked us to find all unique 3-digit, even numbers we could make from a given list of digits, making sure no number started with 0. The key trick to doing this efficiently was to first count how many of each digit we had available, creating an inventory. Then, instead of trying to build numbers, we looped through all possible candidate numbers, from 100 to 998, skipping the odd ones. And, for each candidate, we checked if our inventory had enough of the required digits. This frequency counting approach avoids complex combination logic and handles duplicate input digits smoothly. Hope that breakdown made sense and helped you understand the problem and the frequency count solution. If it did, feel free to hit the like button, maybe subscribe for more Leetcode explanations, or leave a comment if you have any questions or maybe a different way to solve it. And hey, if you're feeling extra generous, the Boba Fund always appreciates support. Keep practicing, keep coding, and I'll see you in the next video.